Hey there, welcome back. I am Aditya, and in this video, we are going to look at the program for depth first search traversal on a graph. So let us begin by defining our function DFS that will perform the depth first search, and it will take the argument start. Start is nothing but the vertex through which we are trying to start the depth first search. So the first thing I'm going to do is introduce a set and name it as visited. So what is the purpose of this set? So this is an empty set right now. Its purpose is to, as we traverse through the graph, I'm going to add the nodes that have been visited, like that have been traversed. So in order to ensure that I do not visit them again and again and cause an infinite loop or something like that. So for now, we haven't visited any node, we haven't traversed any node. So it's an empty one, but as we traverse through the graph, I'm going to add every node to the set, and I'm going to use this to ensure that we are not getting into trapped into a loop or revisiting any node which is unnecessary to save the time. And then I'm going to define a result which is going to be a list. So it will be the result that as we traverse to the graph, the depth first search, I'm going to append the node values to this result, and ultimately this is what I'll be printing on the screen. So that is why I'm naming it as the result. So now for depth first search, I'm going to need recursion, and for that I'll be using a helper function. This time I'm going to name it as DFS all small, and the argument is going to be the vertex. So what I'm going to do in this function is, first of all, I'll mark the vertex as visited. To do that, what I'm going to do is add the vertex to visited set. So visited.add vertex, and also I'm going to append it to answer, that is result, right? So I'm going to append the vertex value to result as well, because now we have traversed it. Now I'm going to look at the neighbors. How do I look at the neighbors of the vertex? I'll iterate over the adjacency list of the vertex, and every element on that list is a neighbor. And what I'm going to do is I'm going to check if neighbor is in visited. Like if this neighbor has been already visited. If it is not, actually, if this neighbor has not been visited, I want to do the depth first search on this neighbor. So recursion call over here, and at the bottom I want to start the function recursion, the helper function, with the start vertex, and at the very bottom of this function I want to finally get the result as the return value. Now let's test this depth first search. How do we do that? So I'll just paste a couple of lines over here. So what I have done is g is equal to graph. It is going to trigger the constructor function, initialization function. So self.adjacency list is created over there. Other than that, I have added the vertices A, B, C, D, E, and F. And then I'm adding edge between A and B. I'm adding edge between A and C, edge between B and D, edge between C and E. So this is the edge. Then I'm adding edge between D and E. So basically, this is how the graph is going to look visually, and that is what I have created. And then I'm printing the depth first search, and I'm starting with A, vertex A, and I'm printing it. What is going to be printed? The result that is being returned. So let's run this program and see how the depth first search works, starting with A, right? So we have an output over here which shows this AB. So when we do depth first search, we are going from A to B, then B to D. From from D, we are actually have the option to go to F, or we have the option to go to E. But as we see, we have gone to E first. So it's something that is random, right? It's not, we could have gone to F, but we somehow chose to go to E. And from E, we have option, we could have gone to F or C. We chose to go C. From C, we have A, but it is already in the visited. So we are not going to go to A. In fact, we are going to go back. Recursion ends there. We come out of it. We are back at E, and now we have the option to go to F, and it's not visited. So we go to F, add it to visited. Now we are at E. no one is left that is not visited. We go back, we reach to D. F is an option, but it is visited, so we are not going to go there. We come out of that recursion call. Now we are at B, and of course there is no option left, so we again get out of it. A, B and C both are visited, so again there is no option. We get out of the recursion. Recursion is over, and now we return the result, and the result is printed on the terminal. So yes, this is what depth first search looks like, and yes, it might feel a little uncomfortable for the first timers. It might not feel friendly. It might not clearly make sense. But believe me, you just need a little practice. You need to go over the function line by line, and you'll be able to see how the depth first search works. And with some practice you'll be able to gain confidence and be ready. So best of luck with that. Next up we are going to move on to see the breadth first search.